Hi, I'm Gobinath Tamilvanan, the Product Marketing Manager for SMUs at Keysight Technologies. We are going to take a brief look at using a source measure unit to measure the current and voltage characteristics of a low power IC. We will cover some measurement examples specifically related to low power IC testing, such as multi-channel synchronous IV measurement utilizing an SMU as power supply, ammeter, voltmeter and digitizer. Sleep current measurement under 1 microamperes with a high-speed SMU, and dynamic IV characterization of the transition from sleep to active state. An SMU simultaneously sources voltage and current while measuring voltage and current precisely. In addition, some SMU integrates pulsar and digitizer function. This allows us to precisely see how low power ICs operates in various test conditions with easy integration in a single box solution. First, let's measure the power on sequence of a power management IC evaluation board using a 5-channel SMU as a power supply, ammeter, voltmeter and digitizer. It's a very simple setup we have over here. The PZ2131A channel 1 is connected to voltage input of the device under test, supplying voltage to the DUT, while the PZ2131A channel 2 to 5 are connected to voltage output 1 to 4, measuring the voltage output of the buck converters. PathWave BenchView Advanced Power Suite accelerates the characterization of devices and circuits in research, development and design verification through quick and easy execution of synchronous current voltage measurements on up to 20 channel SMUs without programming, allowing for immediate review of test results on graphs and tables and making report generation efficient. Connect the PZ2100A and enable 5 channels of PZ2131A. In this demo, use source and sampling mode to check the transient voltage and current measurement on power on. The PZ2131A channel 1 is set to source 0 volt with 750 milliamperes limit current with the power supply mode and simultaneously measure the supply current. The PZ2131A channel 2 to 5 are set to 0 amperes force. With these settings, the SMU will function as a voltmeter. By running a program of this setup, let's check the power on sequence of the device under test. The graph displayed shows time on the horizontal axis and linear scale voltage and log scale current on the vertical axis, and it shows the current and voltage transitions of the power rail and the buck converter when a 5 volt is applied to the circuit. It also shows the change in supply current from less than 100 microamperes before power on to more than 750 milliamperes of inrush current. Next, let's measure the dynamic transition of an MCU evaluation board which is programmed to wake from sleep to active every 1 second to send temperature data through UART. Accurately measuring sleep currents is crucial due to extended battery life and power supply constraints. Low power ICs have a reduced sleep current down to microamperes or even less. To measure these low currents, we will use the PZ2100 series SMU that has a 15 megasamples per second sampling rate and a narrow pulse accuracy of 10 microseconds. The PZ2120A is connected to VDD of the device under test, supplying voltage to the DUT, while the PZ2100A digital I/O port 1 is connected to UART pin as trigger input. The PZ2120A is set to source 0 volt with 100 milliamperes limit current and start to capture the power rail current with seamless current measurement ranging using the digitizer mode with 1 megasamples per second by getting a trigger. Seamless current measurement ranging mode allows for simultaneous measurement of current in multiple ranges, delivering optimal results while allowing a wider range for dynamic measurements. Apply the 5 volt to the circuit and the LED of the DUT will be blinking when it is active every 1 second. By running a program of this setup, let's check the transition between sleep and active states of the device under test. Just send the trigger. The graph shows the current and voltage transition waveforms. After getting a trigger, the SMUs can start measurement immediately, and it can capture the current changes in active states within 1 millisecond and 10 milliamperes, as well as transient currents from active to sleep by the 1 megasamples per second sampling rate and the seamless current measurement ranging. I hope you had fun as we took a brief tour of the source measure unit to look at the current and voltage dynamic characteristics of a low power IC. To learn more about using SMUs for many other application-specific tests such as low current LED, VCSEL sensor and module, narrow pulsed LIV, DC bias sourcing for optical receivers and modulators, data center applications and more, check out the relevant resources available throughout our Keysight University course each month. Start here to solve your design, test and validation challenges so that you can focus more on characterization and less on synchronization.